Alright, we're going to continue. This graph was undoubtedly the best graph in the world. It was really well done. Let's go to the next one. Now you got 15x to the 5, blah blah blah, and 10x to the 5, blah blah blah. So now we have the same degree on the top and on the bottom. Alright, let's go a little faster this time. So you got x and y. Alright, so I know we have a horizontal asymptote at 15 over 10, or 1.5. Because 15 over 10, they're of the same degree, so 1.5. There we go. I know I have, let's see, x minus 1 and an x minus 1 here in the factor form, so there's going to be a hole there. And did I forget to do the hole on that last one too? Oh no, I did it. Nice. Okay. X minus 1, x minus 1, so I know there's going to be a hole at x equals 1. Let's just kind of write that down so I don't forget this time. Hole at x equals 1. Maybe I'll even plug in a 1 right now to kind of see where it'll end up being. 15 times 1 plus 1 is 2 cubed. 1 minus 2 is negative 1 over 10 times 1 times 1 times 4 times negative 2. So negative 8, negative 80. And you got 8 times 15, so it's going to be like 120. Negative 120 and negative 8. So 120 over 80 is going to be 3 halves, 1.5. Really? Right at 1.5? That's interesting. I might have done the math wrong, but that's fine. So what do we got? That's at 1. We have a hole right on that asymptote. That's interesting. Okay, so now at 2 we have a 0 from this. At negative 1 we have a triple 0. So it's going to kind of slow down when it goes there. At 3 we have an asymptote. And at negative 3 we have an asymptote. And at 0 we have an asymptote. I'm going to make that one a different color. Just so I don't forget it. Yeah, let's start graphing. I think we're pretty much done. Alright, I know I've got a 0 right here. And so I know it has to go to, okay, let's just see what happens when we get way off to the side. This here is going to be a positive over positive, so it's going to be a little bit positive. It's going to be a little bit above 1.5. Okay, so that means this kind of goes like this, up here, comes down from here, it goes through here, which means it comes up here, comes back up here, goes through here, must come back up here, come back down here. Did something go wrong? Did I miss that? We have this has to go right through here. 0. Oh, this is a double 0. Yep, I did do something wrong there. So when you get, that's actually, I'm glad I did that. So right here, I went up towards x equals 0. I got to come back down because it's an x squared. Since it's squared, it's got to come back to the other side. And now that's going to go through here and come down there. And that makes sense because I can get myself back to my asymptote. There it is. That's what it should look like. Not too hard. Let's check out Desmos. See what theirs looks like. Yeah, looks pretty similar. Let's look at mine. Oh, way nicer. Way nicer. Alright, I think I might try to go do another one on this video. 5th degree over 5th degree. Let's go fast. Oops. That's y. Alright, what do we got for asymptotes? 10 over 15 as the asymptote, because they're both the same degree, so it's just a over b, 10 over 15, so 2/3. at 2/3. Alright, on the bottom we have an x plus 1 here, so a negative 1. Asymptote. We have a positive 2. Asymptote. This is going to be a hole. At negative 3 we have a 0. Negative 3. At 0 we have a 0. And at 3 we have a 0. And if I plug in a really, really, really big number, I need a right here. It's going to be a little bit below 2/3. So if I plug in a really, really, really big number, it's going to be like 0.66665. So it's going to be smaller than 0.6666666 repeated. Okay, I know that because if I plug in a big number here, this is going to be negative 10 times big and 15 times big, so it's going to be a little bit below. So it goes like, oh, let's not make it red. All right, let's blue one. Okay, so it goes like this. Where's my 0? Or sorry, my hole at 1. So it follows my asymptote. At 2, we have a single asymptote. And it goes through at 0. But what happens at 0? Is it a double? Yep. So it bounces back up. Comes up like that. And then it goes through here. And it goes boom. The only thing I have to worry about is my hole. At 1, I have a hole. Alright, let's plug in 1 and see what we get. We got 10 times 1 times 1, so it's 10 times 4, that's 40, times negative 2, negative 80. Oh, basically it's the same thing as the other one, negative 20. So this is going to be 2/3. Oh, it's right on the asymptote as well. Awesome. There we go. And so there's our graph, and let's see what Desmos has to say about that. What's mine like? Oh yeah, perfect. Look at that. It's beautiful. Alright, catch you next time for the next graph where I will graph a 5th degree over a 4th degree. Bye.